Hello all. We have received a request from few students regarding covering interpreted and compiled version of Haskell programming and how you can use a interpreted mode or a compiled mode for writing functions and then uh, using it to complete or achieve a task. So we are recording a video to discuss just differences and similarities between compilation and interpretation modes of Haskell. So what we will do is we will log into interpreted version GHCI. Now I'm in interpreted mode of Haskell. So we all know that there is a function called as length, which can measure a length of lists. So it is a list in Haskell. We know that we have discussed this in detail in our list lecture series. So obviously the length is 6. We can also measure the length of list like now its length is 10. Now can we write our own function which accepts something as an argument and then measure its length and return it? So we can do that. So let's learn how to do it in compiled mode or a interpreted mode and in both. So let's say I want to define a function called as len which accepts argument. Let's say the argument is of type x, and what it does is it's return. I want it to return a length, so I'm going to make use of built-in function length, and let's say x. So now len is defined as a function. So let's say len, and I'll pass it as my own name as an argument. Now it says 6, and if I pass a list again, now it's working. Now see, it's not a length function directly in from the Haskell. Instead of it is using a customized version of which we are defining, and we can truly customize it. For example, we can redefine this function len, like let's calculate the length of x and minus it by 1. So this is our function. So let's say length of the string will be returned by adding by subtracting 1 from it, so len minus 1. So this is our customized length function now. Now this is we are doing in wholly a interpreted mode. So what is the drawback of interpreted mode? If I exit from interpreted mode, if we exit from the interpreted mode and if we log in again, GHCI, now let's log in into the interpreted mode. Now if I try to use this len function, let's say len Samir, then it's no longer available. So that function or all the variables, all the list, all the members, whatever we do in interpreted mode will live till that particular instance of the interpretation is running. As soon as you come out of that environment, interpretation environment, everything will be lost. So it will be removed from the memory. Now what if we write a program, the same thing in a file, and then we use that file for execution purpose? So let's create a file. Notepad, and let me call this as l1.hs. Now l1.hs is my simple text file. I'll create it, and let's write the same thing that we have written in interpreted mode. Len x is equal to length is the actual function, and then pass some x which is the argument for the length. And now let's save this file. Okay, so it's the same thing that we have written in an interpreted mode. Now instead of writing in interpreter directly, I am writing it in my notepad file. Now if I log in into my interpreted mode, now here the len is still not available, but I can load it now. How we can load it? :load and then file name l1. So it clearly says that there is one module inside this, and we have loaded that module. The module name is len. Now I can use this len. Let's say let's pass some string. Now it measures the exact length of string, or we can even pass any list to it. Len of 1 to 100. So the length is obviously 100, so it's going to work. Now this is how we can use this function in an interpreted mode. We have written the function in the file, and now we are loading this file into the interpreted environment. The benefit of this is, let's terminate the Haskell interpreted mode. Let's clear the screen, Now if you log in again, GHCI, now again of course this lane is not available, but you can easily load this function back in your environment. How you can load this function easily back is simply say :L and then file name in which it is written, and then the len is back in action. Now it's working. So this is the benefit of writing the programming in a notepad file and then loading the particular thing in a GHCI interpreted mode. So it will be available for you at any time of instant. If you directly write everything in an interpreted mode, as soon as you terminate your interpreter environment, the code will be lost. Now let's see what is a compiled version. Let's terminate this. Now you can use GHC compiler and give the file name l1.hs. Now what is this? It says the IO action main is not defined in module main. So every program needs an entry point to execute in the compiled version. Now here in our file l1.hs we have not mentioned any entry point for our program. So we have to mention that. So what I will say is main is equal to, let's say we want to print the output of this program. So print is another function which will take argument which is len, and we will say x. So what we want to do is we want to print the result generated by length function which we are defining, which is accepting an argument of type x. So this is what we are doing. Now if you try to compile this GHC and then say l1.hs, there is one error, x. So here our file is not clearly specifying what is the meaning of x here. So if we do it like this, like say len of 10, now it will compile successfully. Sorry, obviously my len function is supposed to work on a list and I'm passing one digit, so it's not going to work. Let me pass a string, let's say INTI, or let me pass a string HSKELL Haskell. Now it should work. Let's go back to the try to load the module or the compile the program, and it compiled successfully. Let's compile it again, l1.hs. So it compiled successfully. Now you can execute L1 directly and it will tell you the length of the string Haskell. So the length of the Haskell is 7. 1, 2, 3, 4, 5, 6, 7. So the output has come as 7 on the screen. So now we are hard coding it. We have to hard code it. Like if I just don't want to use here the direct string, if I still want to use some input y, then what we can do is we can define this y in the program. Y is equal to, let's say, Haskell, and now also we can compile this l1.hci. So l1.hs has been compiled and now you can execute l1 and the output is still 7. So this is the compiled version of the Haskell, in which you have to clearly define each and every parameter of a program, and also you must specify the main, which is the entry point for the execution, which is not compulsory in the interpreted mode. If you want to just convert the same program in interpreted version, just remove this entry point that we are adding, and also now there is no need to define this argument. So now len x is equal to length x. So this is the function that we want to execute. And how we can now if you try to compile, obviously this is the error because it do not have an entry point. Now if you go back to the interpreted environment, then you can load this module, load l1, and the program will be loaded. Now I have access to the function len and then pass string to it and it works. So this is the difference between compiled version of Haskell programming and the interpreted version of Haskell programming. While uploading the assignments for the submission, you can use this interpreted version, or if you want to use a compiled version, no issues. Just define each and everything very neatly. For example, you have to define an entry point. You must pass the argument to the print. So the program knows what it has to print. Let's say it has to print the value returned by len function, and the argument to len is x or maybe some other alphabet z. But in this case you have to define what is the meaning of z also, like z must be initialized to something. Let's initialize this now to 1 to 10, and now this program is ready for compile and then execution. Let's come out of this interpreted mode. Let's compile the program ghc l1.hs. sorry, I should use ghc l1.hs file. So it is compiling. Now compilation has been done. Now you can execute this l1, and obviously the length is 10. I hope you got the difference between the compiled and interpreted version. Thank you.